Today we'll be talking about special items within Python. We're talking about lambdas, mapping, filtering, reducing, jump tables, and maybe one or two other things. But that's going to be the main focus for today and really talking through how to use these items and when we would use them and the sparingness between them all. Okay, so to get started here, I'm going to create a function called greeting that's going to take in a parameter called name, and what it's going to do is print out hello and whatever is supplied for the name. I'm going to go ahead and save it, and it is saved as my module. I'll come in here and I'm going to import that in, and when I do so, I now have the ability to utilize what is made available to it, and that is my function called greeting. Now, if I tried to go in here and utilize it by itself, let's just say I supplied Nando, it's going to say, hey, greeting is not defined. I don't know what you're talking about. So for me to use this as it stands, I'm going to need to come in here, specify the module itself. I'll do greeting, and then I can feed it whatever it is that I'm trying to give it. So hello Nando is then returned. Now this is cool and fine and dandy, but let's say I wanted to do this same very thing from a different perspective. Well, this is where lambdas come in, excuse me. They're very hasty definitions of functions, if you will. And their construct is something like this, where we'd call upon lambda, we'd feed it arguments, and then the very expression that we're trying to do. Now, if I still wanted more assistance on that, well, I could do something like this, where I could get that help that I'm looking for. Now, there are certain things that are made available to me as well, and I'd be able to look at those with my dir. Now, let's create another simple function here, and with that simple function, we'll look at doing it as we normally know how to do it, and then we'll look at doing it from a lambda perspective. So I'll come in here, I'll do add, and then it's going to take a parameter of x, and in return, it's going to return x plus 10. Fine and dandy. Let's run that. Cool. So I'll now come over here and I'll do add, and I'll just give it 5. And it returns 15 for me. That's awesome. Now I'll go in here and I'll comment this out because I'm now wanting to do it from the lambda perspective. So understanding the construct here and looking at my help file and everything else that's available to me, I'm going to have some instantiation of it, and this instantiation I'll just say is ABC, and within there I'll say ABC equals lambda, and then that's going to be my argument. My expression is going to be, hey, a plus 10. Again, whatever's being fed, this will be my argument. It will be declared as a. A now is shown here, or better yet, let's do this, right? Because we see x as a parameter here. Here's x as my parameter. We see x here is something within my function that's being executed. Well, here's x being executed within my lambda, if you will, there. And once we do that, we can then call upon it. So I'll do ABC, i.e., the very function that I'm declaring, in this case, lambda, and then I'll give it a particular item. We'll do 6 this time, so there's no confusion. And I'll run this, and we see it actually happened. All right, so these are very one-off use cases of sorts where I just need to, on the fly, declare a function and utilize it, and it's not something that I want to utilize over and over again. I can use lambdas for that. Now, let's look at it from a different perspective, where we're going to utilize kind of the same construct here, where we're going to do a normal method for doing a function, and we'll say, hey, we'll call it mul for like multiplication. we're going to feed it A1 and A2 as parameters, and in return, it's going to do a return statement that then allows us to multiply those items and return that output. So when we go in there and do that, we'll then get something like so. So let's run this. Cool. Now I'll come in here and I'll do mul and I'll feed it 5. I'll do a comma and I'll do 6. And what do we get in return? We get 30 because we know 5 times 6 is indeed 30. Well, let's look at doing it from a lambda perspective. We'll call our instantiation mul2. In this case, mul up top is the function. Mul2 is going to be that instantiation. It's going to kind of serve like a function. And we'll do mul2 and we'll do something like lambda. We'll specify our parameter A1. We'll specify the parameter A2. We'll do a colon, and then we'll go into what our expression will be. In this case, we're going to multiply A1 with A2. That's it. So I'll run this again. It is now declared, and now I can actually call upon it and use it. And doing so would look something like this, where let's just do mul2, and we'll specify, we'll go up 1, 6, and 7, and in return we get 42. So both of these allow us to essentially do the same thing. I'll reserve my definition when I'm declaring my function for something that I'm going to use over and over, maybe large scale, and my lambda is going to be very hasty in nature, kind of like a one-time use of sorts. Now, let's look at mapping. All right, so mapping is going to return a list of the results after applying a given function to each item of the given iterable, whether it's a list, tuple, what have you. All right, this doesn't work on floats, and our syntax is going to be something like this. We'll do map, we'll specify function to apply, we'll do a list of tuples, right, which is not a list of tuples, list of inputs rather, and then we'll wrap it up there. Typically these will be used with lambdas, but not necessarily a thing that we have to do. And if we want to get help on it, well, you guessed it, we could utilize the help method and feed in map. We also have a number of things that are available to us when we look at dir of sorts. Now, let's get in here and we'll declare num, and num will be, I don't know, a list. And that list will have a string of 1, it will have a string of 99, and we'll do a couple more strings. We'll do -22, we'll do 1, 2, 3, and then we'll wrap up our list. Now, we're going to create a new list, right, or a new num rather, and what we'll do is we'll do list, we'll do map, we're going to specify what we want to convert it to, and then we'll specify the data itself. So we have num, which right now, or when I run this rather, will contain, let's look at this. Num is indeed a list, and num itself, when we look at the items in there, well, they are all strings, right? So I'll do one of them, right? So we see 4 items in there that are indeed strings to include this -22. So when we specify that data, we want to apply int, we want to cast them as ints, and we'll utilize map to do that. That output, we want it to be a list, and we're going to store that as new list. So let's run this and check it out. Okay, so num is still that string of lists, or that list containing strings rather, and then new list itself, well, that's going to be a list containing ints. And again, we could come in here, new num, we could specify a particular index, and we see that is indeed an int. So let's look at it from another perspective. All right, this other perspective would be something like this. We'd call it, I don't know, new, and in there we'll declare a list, actually, that we're going to utilize map with, and now we're going to try to make those a string, right? And the things that we're going to turn to a string is new num. Those are the things from the previous step that we had converted to a to ints, right? And with this now being something that we've done, we can just kind of go back and forth with this. So I reran it, and now when I look at new is just like num, right? But new is different than new num. So we had num, which was a list of strings. We converted them utilizing map, casting all those items at once to an int, and then we went back in and mapped or cast all those items to a string again. So we can see with map, we can mass apply a given function to a subset of data, as opposed to me looping through each one of these and trying to convert them. I can just convert all those items at once. Now, let's say we wanted to get in here and do a little bit more with it, right? Say we wanted to apply the addition function and create a new list to all these items without map. I'll just do one of them, and this is what it would look like. So we come in here and we have numbers. I'm going to say we have a tuple 1, 2, 3, 4, and we'll say my list. And within my list, well, it would just be an empty list. We'll do a for loop, so we'll say for I in numbers. And what we want to do is declare something new called out, and we want to utilize the function that we had before, which really does addition, but I've already erased it. So rather than, actually, we'll come here and declare it again. So we'll do def, I'll call it addition, we'll feed it a parameter, and what it's going to do is return x plus x. Cool. So now that we've done that, I'll come in here and I'll call upon that function, and the very thing that I'm going to feed it as a parameter is I. And I'll store whatever that is out. Well, then I'll come in here and we'll utilize my list that was empty, and I'll utilize the append method, and what I'm going to be appending is the contents of out. So we'll run this. Okay, cool. So when I come in here and I now look at my list, right, I see those very items of sorts. All right, so we had 1, 2, 3, 4. We then looped through those numbers, applied that function that we had, and then we created a new list. So we're essentially utilizing all those items of sorts, just doubling it. All right, so 1 became 2, 2 became 4, 3 became 6, 4 became 8. Now this is all fine and dandy, but let's say I did not want to do it like this and I wanted to use map. Well, let's go in here, let's do some doc strings to kind of cancel this out, and I'll utilize this same function, and now we'll utilize map. All right, so we'll say, hey, numbers, let's copy this, numbers 1, 2, 3, 4, that's going to be a tuple, right? And we'll then declare results. And result is going to be where we're going to spit everything that we're going to map, right? That's going to be that new list, if you will. So we'll do map, we'll specify addition, because addition is this function up above, and then what we're going to feed it is numbers. What we're going to feed it is numbers. And from everything that's stored there, we're then going to print it out. We'll say list, and we'll do result. So let's run this. Let's look at what we get. Cool. Well, we get the same thing, right? Our difference here is we utilized map here, and here we just did a for loop. Again, map allowed us to apply some overarching function to a particular data set without us having to loop through it like we did there. So there's some good use of utilizing map, and it's very useful. Now let's look at filter. Well, much like the other things that we've been talking about, we could come in here and we could do help filter, and we see those items, and we're able to get a little bit better understanding of what filter does for us. We can also do a directory listing on it, and essentially it's going to return an iterator yielding those items of the iterable for which function is true. So what does that really mean for us? Let's break that down. Well, as the name suggests, honestly, it does filtering. The filter item itself, it helps to create a list of elements for which essentially functions return true. Here's the short and concise example. Filters are truly given sequence of the help of a function that tests each element in the sequence to either be true or not. So let's look at it. Well, we'll get rid of this. We'll come in and we'll do def fun, and I'm going to put in here that it takes a parameter called variable, and what we'll feed it, or what's going to be within there, is letters, and we're going to have a list of letters. We'll do A, we'll do actually let's do E, we'll do I, do O, and then we'll do U. We'll close that list up, and then we'll do an if statement. We're going to say, hey, if the variable in letters, right, or rather, if variable in letters, then we want it to roll into another block, and we want to return true, else we wanted to return false. Okay, cool. So let's run this. All right, so I'll come in here, I'll say fun, and I'll say we'll do C, right? So false. We'll run it again, and I'll do E. Right, and it comes back as true. So you kind of get the point there. Now, if we wanted to do a little bit more with this, we'd do something like this, right? So I have my function, and we already talked about what it did and had an example, but now I'm going to feed it a sequence of characters. I'm going to declare a new list, and within that new list, I'll also just utilize well, let's get rid of this, right? And from within that, we're going to say, hey, for each character in sequence, store it as S, do fun, utilize S as the variable, or rather parameter that we're feeding to fun, store that output as ands. If the ands equals true, then we want to append it to this new list that we've created. Okay, simple enough. Well, let's run that. Okay, so that is now ran, and we can come back over here and we can do new S, and we can look at the contents of it. Well, that's interesting because, hey, when we look at this list of items, this sequence, the only thing that renders as true are these two E's, and they got added to our new list called S. Well, that's cool. Now, let's say we wanted to utilize filtering, right? Because that may be a lot of work for everything we just did. Well, filtering is going to be something like this. Let's say we're going to use this for filtering, right? And I'm going to come over here and we'll pull out another Python shell of sorts. Okay, so we're specifying filter. We're going to feed it the function called fun, which we've done up there. And what we're going to feed it as an argument is sequence, which we have here. And then that's going to be stored as filtered. I'm going to print out the filtered letters R, and we're going to loop through each item in filtered, storing it as S, and then printing S out. So filtered itself is going through utilizing the function with the sequence and then returning that output for us. So let's run this. Okay, cool. And we see it being done. There's the very print statement that we had. And when our function executed via filtered, we got the output of it there. Now, let's look at this, for example, as we transition over to being able to do a little bit more. And the next thing we're going to do is straight up jump tables. All right. So with jump tables, these are structures containing functions using lists or dictionaries. So we have several functions here: wheels, doors, horn. Each one of them take two parameters called name and action. And we're doing some string formatting here where the first item is going to be there, the second item is there, and then the third one is there. And what we're feeding it is name and then action twice. Kind of the same thing for most of them, except the next two are going to be for. Well, we call upon those functions and we feed it the very items that we're talking about. Well, let's run this. Okay, it ran, and we need to put a print statement here. Right, because Python did exactly what we wanted it to do, but we didn't tell it to print. So let's run this again, and now we get Ned. The wheels on the bus go round and round, and then we have the subset of that being done afterwards. So when we're using jump tables, we have the ability to really increase what we're doing. And what we'll do is we'll also declare 3 more functions, and we'll utilize a dictionary with a value key pair. So we have a value of morning and a key of morning, and then a value of coffee, of a key of afternoon, and a value of work, and a key of evening with relax. And we're asking for input, and within our input, depending on what time of day that they tell us, well, then we're going to print out that action that's being done at that time. So let's go ahead and run this. All right, so running this, it prompts me for what day, time of day it is, which we see here. I'm going to feed it evening, right? And when I give it evening, that function is then going to run that evening function. That function is going to run based upon the value of that key, and in this case it's going to be relax. So the function relax is going to run, and it's going to say watching a little Netflix. So let's do this. Evening. Cool. This is what I know that you are doing, watching a little Netflix. So let's run this again, and this time we'll say afternoon. Well, when we do afternoon, that's going to be the time of day, and that value is then what's going to be utilized as far as what function is going to run, and that's going to be work. So let's do afternoon. Okay, I know what you're doing. You're sitting in a meeting. Cool. So this is helpful, and we're able to do this with what's called jump tables. Now, the last thing that we'll talk about is reducing. Okay, so reducing is really useful when we're utilizing functions for performing some type of computation on a list and returning the result. This could apply to rolling computation or sequential pair values in a list. So my example here is a function called multi. It takes in one parameter, and I'm going to call that parameter my list. The first thing it's going to do is take the first item out of the parameter that I fed it, which in this case will be a list, store it as prod. Then I'll take whatever the length is of that list itself, and I'll loop through that number of times. The first item that I'll pull out will be a 1. And the 1 will be I'll utilize my list with that index, and then I'll multiply it with prod, and then store it back as prod. I'll return prod back out, and that will be what it gets print. Now, the list that I'm going to feed it is 4, 3, 2, 1. Now, let's run this, and then let's go back through and look at that data set. So what we get in return is 24. Okay, so when this first runs, the first item in our list at index 0 is going to be 4. So 4 gets stored as prod. We're then going to loop through, starting with 1, going up, but not including the total length. So the length of my list is 4. So what we get back is, in our range is 1, 2, 3, and we don't include 4. The first loop is going to be 1, so 1's going to be I, and we're going to take my list, and what's at index 1? Well, 3. So we're going to multiply that with 4, because that's going to be the first item, and that becomes 12, and that's what gets returned here. All right, so we get that returned. Awesome. And then we're going to loop through and do it until that list is exhausted. So during the first pass, we'll get 12. During the next pass, we'll get 2 times 12, bringing us to 24. And then during the third pass, the last one, we'll get 24 times 1, bringing us back to 24. Now, reducing is useful in that manner because we were able to go through and multiply items in our list X amount of times to get the actual item that we cared about. Now, I said reducing was going to be the last thing, but I really want to touch on hashes very, very quickly. And for us to do this, well, I'm going to come in here and we'll import OS. We'll look at where we are on our system, and we see a number of things. Actually, let's do get CWD, and we can see our actual path. Okay, awesome. So I'm going to come in here, and I'm going to change my path to the temp directory. So we'll do ls chdir, and then we'll come in here. And as you recall, we're going to do double slashes because one is going to get canceled out, all right, or escape. So we'll change to temp, and we'll close it up. And for sanity checks, I can do get CWD on that, and I'll see that I'm in temp. All right, well, let's do a list dir so I can see what I actually have in that directory. Okay, so for me, I have this, I'm just going to take a random file. I have this VMware VMSS system log file. So I'm going to just copy that, put it in my buffer, and I'm going to declare a variable called file, and I'll put that file name down. Okay, awesome. So I'm going to do another declaration, and I'm going to do algorithm, and what we're going to look at is hash lib, and we'll do MD5 open close. Now, check this out, because we get this error, and it's like, I don't know what hash lib is. Well, we needed to import in hash lib, and now when we run that, we get that being stored. So let's just print what's in algorithm, and we see that it is indeed a hash object. All right, so while we're here, let's look at some of the other things that hashlib made available to us. Well, we see MD5, we see a number of other hashing algorithms. So Awesome. Now, let's utilize this. And for us to utilize this, I'll create something else called file binary. And what I'll do there is almost like I do with any other file, I'll open a handle to it. And the very thing that I'm going to utilize is what I stored in file, which is that VMSS file. Now, I'm using a relative path because it's in my current working path, and I'm going to open it up with RB. RB allows me to open it up in binary read mode. Now, when I do that, you don't want me with permissions. Okay. All right, so plan B. Let's go to my desktop. So I'm going to ls list dir, or change dir rather, and I'll go to my desktop. Users wolf.sandbox desktop, and I'll close that up. We'll do it ls list dir on that, and we see a number of things. I'm going to take this unfiltered files text that I have here, and I will store that as file, and in there I'll come back and I'll be good to go. Now, because I can't do my up arrow here to do my previous commands, there's some shortcut that I can do within here, but I don't recall it. I'll just copy and paste it again. So file binary, I'm opening a handle to it. I've specified the file. That's going to be a relative path because I'm currently in that working directory. I'm going to open it with a handle of RB. If I was confused, or if I wanted to verify rather what mode I have it opened in, well, I see I have it open in RB. So what I'll do now is I'll do something like file read, and I'll do file binary, and I'll actually read said file in a binary read mode. That is now stored as file read, and I'll supply that to algorithm. We'll do update, and then we'll do file read. So what I get back, actually, when I do that, is the actual hash of that file. So let's walk through this again. So we declared a file, or declared a variable with a file name rather. We opened a handle to the file, and we did it in RB, which is read binary mode, all right, or binary read mode. I looked at the mode to verify. I read the contents of it. I then utilized the algorithm function with the update method, and I specified file read. I was then able to utilize algorithm, and I utilized the hash digest method, and it printed out the hash. Now, if I were to do this on a number of systems and files, this is that one-way computation, so I have some type of integrity to be rest assured that that file hasn't been unchanged. This is a security feature that many people utilize so they can identify either indicators of compromise or maliciousness being done on a system. So with that, that's kind of all we had for today. So we went through a number of things: lambda, reducing, filtering. We looked at mapping, kind of talked about how to get a hash off a file, and we feel pretty accomplished. We'll take the things we learned here today, and then we'll actually utilize them in our day-to-day activities. Until next time, take care.